In section 5.5, we're going to talk about two special right triangles that really you're going to have to memorize. You're going to see them so often. And the two triangles are your 45, 45, 90 and your 30, 60, 90. And so in your 45, 45, 90, remember that the smallest angle is always opposite the shortest side. Well, if the angles are equal, that must mean the opposite sides, the sides opposite the equals angles, are also going to be equal, are also going to be congruent. So we're talking about a right triangle whose legs are the same length. Now, if we were to use Pythagorean theorem here, so if I had a right triangle and I knew these were both 45-degree angles and this was length A, that would mean this would be length A. If I were to use Pythagorean theorem, c squared is a squared plus a squared. A squared plus a squared is 2a squared. Take the square root of both sides. And what you're going to find is that for this type of triangle, the hypotenuse is always whatever the length of the side is times the square root of 2. Times the square root of 2. So in a right triangle whose angles are 45, 45, and of course the 90, the legs are congruent, and the hypotenuse is always that number multiplied by the square root of 2. So if I had a right triangle here that was 7 and 7, I would know my hypotenuse is 7 square root of 2. So you just kind of memorize that. A times the square root of 2. All right, so let's look at these two 45, 45, 90 triangles. All right, so I have that this is 45 and this is 45, so I'm going to give them both single arcs. So if this leg is 5, that means this leg is 5, which means this hypotenuse is 5 square root of 2. That's what you have to memorize. The hypotenuse is the square root of 2 times the leg length. All right, so here if this is 45 and this is 45, we would know that, and we have 6 as our hypotenuse here. 6 squared is going to equal a squared plus a squared, and we want to find a. So 6 squared is going to equal 2a squared. 6 squared is 36. So I'm going to say 36 equals 2a squared. Divide both sides by 2. 18 equals a squared. Now if I want to find a, I take the square root of both sides. The square root of 18 is the square root of 9 times the square root of 2. The square root of 9 is 3. 3 root 2 is a. So this side is 3 square root of 2, and this side is 3 square root of 2. And let's check. The hypotenuse should be 3 square root of 2 times the square root of 2. Square root times square root is just the number under the radical, which is 6, which is what my hypotenuse is. So that's your 45, 45, 90. There's another triangle called the 30, 60, 90. And that's where, remember, the shortest side is always opposite the smallest angle. So this one would be my 30-degree angle, and this would be my 60-degree angle. And there's my one. There's my right angle. And so the description in words here is whatever the side opposite the 30 is, the side opposite the 60 is that times the square root of 3. and the hypotenuse is 2 times that. Shortest side times the square root of 3, 2 times the shortest side. That holds for all 30, 60, 90 triangles. So this is the triangle I just drew, only I drew it on its side. And you see here, it would be best to memorize the sketch. So when I'm taking geometry or when I'm taking trig, I draw these triangles 15 times a day. 30, 60, 90, 1, 2, square root of 3. If this is a 5, that's 5, 5 square root of 3, and 2 times 5. You can multiply them by numbers. So you memorize the 30, 60, 90 triangle. And remember that the side opposite the 30-degree angle is A. The side opposite the 60-degree angle is A times the square root of 3. And the side opposite the right angle is 2A. And so the length of the longest side is the product of square root of 2 and the length of either congruent remaining sides. All right, so I'm sorry, if the length of the longest side, which is the hypotenuse, is the square root of 2 times the leg length, then it must be a 45, 45, 90. If the length of the hypotenuse is 2 times the shortest leg, then the angle opposite that leg must be 30. And I have always drawn my 30, 60, 90 triangles. That's a 30, that's a 60, that's a 90. 1, 2, square root of 3. This is saying, you know what, you could make this a 1 and you could make this a half. Why you would want to have fractions, I don't know, when you can deal with whole numbers. But those are your 30, 60, 90 triangles.